Today we are starting a new chapter, chapter 11. We're actually skipping 11.1, so we're going to start with 11.2, surface and lateral area. And we're going to start with two three-dimensional figures. The first is a prism and the second is a cylinder. So our objective by the end of the day is that by the end of the day you will be able to find both the lateral and surface area of prisms and cylinders. However, another objective, which isn't stated here, is that as we are now in chapter 11, we are quickly coming to the end of our time together in geometry. And I have up until now always provided you with template notes, that is, notes that have blank spaces where you need to just fill them in so you know exactly what notes to take. That, however, is not the way things are going to work starting next year for you in Algebra 2, and certainly as you go forward in college, you won't be given these types of template notes, or generally will not. So you'll have to learn how to take notes on your own. And so now that we are ending our geometry time together, I am not going to give you template notes to help you get ready for next year, but hopefully it will be pretty obvious where you need to take notes. And so if you need to, you can always just pause this video and take your own notes for chapter 11. All right, so let's get started here. So we're going to start with a 3D figure called the prism because it's pretty much the easiest figure to start with. And there are lots of 3D shapes, so we'll start with the easiest, the prism. Okay, the definition of a prism is a 3D figure with two bases in parallel planes, and all the other faces are rectangles. All right, so there's an example. These two triangles, the one in pink and the one at the bottom of the shape, are the bases. The things are any of the polygons that make up the prism are called faces. So that face in yellow, that rectangle in yellow is a face, and the base is a face. If a face is not a base, it's called a lateral face. So every polygon is either one of the two parallel bases or it is a lateral face. And then the lateral edge, which is sometimes called the altitude, it's the edge that that goes along that goes from one base to another along the side of a lateral face. And in a right prism like the one we're looking at here, it's also the altitude, the height of the shape. And there are lots of different types of prisms, and we name them based on, we name them after the base. So the example here would be a triangular prism because the shape that make the bases are triangles. You can have a square prism, a rectangular prism, a pentagonal, a hexagonal, an octagonal, whatever. Any of the shapes we've learned in the past, any polygon, you can make it into a prism. All right, and perhaps the most famous prism is one like this. This is a picture of Pink Floyd's Dark Side of the Moon, their album, but it is a optical fact that if you take white light and shine it into a prism, the prism will actually break up that white light into its 7 component parts that make up the rainbow of visible light. And one of the things a prism does is that. All right, so again, let's go through the definition of prism as a 3D figure with two congruent and parallel bases. This might be a time where you want to take some notes. The bases are the polygons that are congruent and parallel to each other. A lateral face are the faces that are not a base, one of the polygons that makes up the prism that is not a face, that is not a base. The altitude or height is the perpendicular segment that joins the planes of the bases, or it's also the length of the altitude. All right, moving on. Right versus oblique prisms. That so far we've only talked about right prisms. On the previous slides, you talked about right prisms. That is prisms where the base and the lateral face make a right angle. And that'll be the type of prism we do almost all the problems on. However, not all prisms are right. A prism may lean a little bit, and if so, it is called an oblique prism. So again, a right prism is a prism where all the lateral faces are rectangles, and a lateral edge is an altitude. All lateral sides are perpendicular to the base. That's what makes it a right prism, the fact that they're perpendicular to the base. An oblique prism, some or all of its lateral faces are not rectangles. They could be they could be parallelograms. And the base and lateral sides may not be perpendicular. So let me show you graphically what's going on here. So there is a right prism. Again, kind of looks like a box. At least this one, because it is a rectangular right prism, has a 90-degree angle there. Here's a similar prism that is an oblique prism that is not a 90-degree angle. And so if I want to find the height of this prism, like there or there, the height of the prism is just like when in a 2D figure, it must be perpendicular to the base. So the height is the distance from one base to another that is perpendicular to both bases. So it may actually, if it's a oblique prism like this, the altitude may be outside of the prism as it's drawn both times here. All right, let's talk about surface area. Surface area is just the total definition, the total area of all the surfaces of a 3D object. If you add up all the faces of a prism, you get its surface area. So for example, right here is a rectangular prism. If I take the area of the top and add that to the area of the front, as well as add in the area to the left, as well as add in the area at the bottom and the back, and finally the right. If I add up the area of all 6 of the faces of this rectangular prism, I will get its surface area. You just have to add up all the faces. Okay. Here's another example of what's called a pyramid, which we'll get into in a little bit here. But this pyramid also has, we're adding up, you can see the bases of this the faces of this pyramid are all being added together to get the surface area. The lateral area, by definition, is the total area of the lateral faces of the 3D object. So you can think of it as you can either add up all the lateral faces, or you can take the entire surface area and then just subtract the area of the bases. All right, so if I have that shape, it has these 5 faces. The front is part of the lateral area, the right is part of the lateral area, the back is part of the lateral area, the left is, and the base is not. It would not be part of the lateral area, but of course the base would be part of the surface area. All right. To do surface areas, one way that one can do them, or the one way that's suggested, is to be able to do nets. That is, you need to be able to visualize all of the sides. So imagine if I had this shape here. This is a rectangular prism. And imagine if it were sort of like a wire frame, and then with pieces of plastic put around it, as it's done right here. I could unwrap that plastic. So here you can see I'm sort of pulled the blue side down a little bit. I'm starting to pull off the side faces. I'm continuing that, doing it more and more. And now finally, you can see here that this is what's called a net. And you can see why this would be much easier to figure out exactly what the surface area is by making it 2-dimensional, by taking this 3-dimensional shape and taking each of its component polygons and putting them together in a plane so that I can see them together. You can see how that would be useful to try to visualize a side and use it to try to find the surface area or lateral area. Okay, so that's called the net of a solid. And again, it looks something like that. So you can see exactly how to calculate the net of a solid, or excuse me, the area of a solid by each of its different pieces with its length, its height, and its width. All right, I want to show you an example of, so this is a net of a solid right here. Look at it right here and see if you can, in your head, put this together and figure out what kind of solid it is. You fold it here, 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 and here, and this is a rectangular prism. All right, let's do another one, do it the other way around. Let's start with a rectangular prism and turn it into a net. So if you take this one and you can unfold it, and finally the last 2 pieces come down, and you can see how that was that net there. Here's another example of a net that's unfolded a different way, and again, another net there. All right. Finally, here's a quick quiz for you to see if you can figure it out. Which of these 3 shapes, A, B, or C, is going to be the net of the shape over there on the left? You have about 10 more seconds to figure it out in your head. See if you can sort of fold up the shapes A, B, and C. Which one of them is going to make the actual shape there? And the answer would be B, would make the same shape. All right, so again, you need to be able to visualize the sides of a net. And once you do, as it is, as this example here shows, then it's relatively easy to figure out the area of all the different pieces. So if I asked you to find the surface area of this one here, you would just have to find the area of each of the 6 different sides by taking the formula of width times height and multiply them out, and you could add up all the individual pieces to come up with your surface area. All right, so try these example problems. Example problem 1A and B. You should push pause and try them right here. And once you have done them or get stuck on them, then come back and continue with the video, and I will show you how to do them now. All right, so number 1A is asking us to use a net. And so if I were to take this shape and unfold it, if you will, it would look something like this, where there's that 4 feet, that would go here and here, and here and here. The other 4 feet would go here and here and there. And then finally, the 10 feet would go here and there. So now I can use this net to calculate the area of each of the individual sides of the prism. So the one in the upper left, that 4 times 4, that would be 16 square feet. 4 feet times 4 feet is 16 square feet. That little square is also 16 square feet, 4 times 4. And now I have a 10 by 4 lateral face. 10 times 4 would be 40 square feet. Another 40 square feet, another one, and finally a last one. And so then I just need to add all these up, the 2 16s and the 4 40s. When I add all of those up together, I get a final answer of 192 square feet. All right, when I look at number B, it's not asking me to use a net, just to use the formula. So when I look at this, I see I have 2 bases that are right triangles. I can see that they're a right triangle because that one on the bottom there has a right angle in it. And of course the formula, so the right triangle is with a base of 3 inches and a height of 3 inches. And of course the area of a right triangle, or any triangle, is a base times height times 2. And I can easily figure out the base and height used because it's a right triangle. It's 3 times 3 divided by 2. So the area of one of those 2 right triangles would be 4.5 square inches. There are also 2 lateral faces that have a base of 3 and a height of 10. Those are the ones that are partially obscured by our view on the left and the right. And of course the area for a rectangle is just base times height. So that would be 3 times 10. So the area of each of those 2 lateral faces on the left and the right would be 30. And then finally, I've got one more rectangle, which has a height of 10 and a base of this red line right here, of this red line right here. And I don't know what that is. I need to calculate it. But luckily, I have this makes up this triangle here, and it's a right triangle. And so I've got 3 sides, A, B, and C. And of course, we know our Pythagorean theorem that a squared plus b squared equals c squared. So I can use that to find my side C. So it's 3 squared plus 3 squared is c squared. So that would be 9 plus 9 is c squared, or 18 is c squared. So c must be the root of 18, which if I put into a calculator is equal to about 4.24. I could also have done this using special right triangles. Because it's an isosceles right triangle, I know that the ratio of the sides is n root 2. In this case, 3, 3, and 3 root 2. And of course, 3 root 2 is 4.24. So now that I have the base as well as the height, I can use that. I know the base is 4.24, as we just figured out, and the height is 10. So I can multiply that out, and I get to the area is 42.4. Right. Now that I know the area of each of the individual sides, I just need to add them up. So I've got 2 triangles that are 4.5 each. So when I multiply those out, 2 4.5s is 9. The 2 lateral faces that are 3 by 10 are both 30. So 2 of those would be 60. And I've got the one final one that's a little bigger. That's the lateral face is a little bigger. It's 42.4. When I add up 9, 60, and 42.4, I get our final answer of 111.4 square inches. All right. The next problem, again, once again, I suggest you pause, try these problems on your own, and then you can push play to see how you did. All right, it's asking us to classify the prism. Well, the bases of that prism are a pentagon, so the base has 5 sides. Therefore, we would call it a pentagonal prism. The bases are regular polygons. Find the area of the prism. I'm sorry, find the lateral area of the prism, excuse me. Find the lateral area. Okay, the lateral area is made up of 5 rectangles. Each one has a base of 5 and a height of 11. So that would be 55 for each. And we have 5 of them. And so 5 times 55 would be 275 square centimeters. Okay. And then part C asks, if the area of each base is 43 square centimeters, find the surface area of the prism. So the surface area is simply the lateral area plus the bases. So if I have a pentagon that's 43 square centimeters, then 2 of them for the 2 bases would be 2 times 43, or 86. And if I add that to my 5 lateral faces, which we just figured out earlier was 275, add those up to get the surface area, and the surface area would be 361 square centimeters. Now let's talk about a different 3D figure called the cylinder. The cylinder is a 3D figure with 2 parallel circular bases connected by a curved surface. We just finished with a prism, and you can think of a cylinder kind of like a prism. They're similar to prisms because they have 2 parallel bases that are connected. The difference that in a cylinder the base is a circle, not a polygon. So it looks something like this. And I've defined it and talking about it as a circle, and a cylinder may have oval bases, but we're only going to look at circular ones. So we're just going to talk about circular cylinders. Whenever I say cylinder, I mean a circular base, but to be technical about it, a cylinder may have an oval base as opposed to just a circular one. All right, and so those are the bases. That's the radius of my circle, and that is the height of my cylinder. Okay? And cylinders are everywhere, right? When you have cans are cylinders. Oil drums are cylinders. There's drums of stuff. Toilet paper roll or a paper towel roll, right? All these are cylinders. And my favorite cylinder is, of course, if you're a Muppets fan, beaker is a cylinder with a little hair on top. All right, so there is a cylinder. And just like we had right and oblique prisms, we can have right and oblique cylinders. On the previous slide, we talked about right cylinders. That is, they go straight up and down. They have right angles. However, not all cylinders are right. A prism may lean. If so, it is called an oblique cylinder. So a right cylinder is a cylinder where the segments joining the centers of the bases is an altitude, and they're perpendicular to the base. In oblique cylinders where that's not the case, a cylinder where the segment joining the centers of the bases is not an altitude, it is not perpendicular to the base. So for example, there are the examples there. On the left, I have a right cylinder, and you can see that the radius and the height and the line that makes a straight line between the 2 centers of the bases is a right angle, as opposed to the oblique cylinder. That is not the case, that it leans. And just like the previous slide where we talked, just like for prisms where we talked about you need to be able to visualize nets, you need to be able to do the same thing with cylinders. The net of every cylinder is exactly the same thing. You've got the bases are both circles with a radius of r. We know how to find the area of those. It's just pi r squared. And then the remainder is a rectangle. Again, if you take a piece of paper and you roll it together, so you take one side of the paper that it touches the side that is parallel to it, you have made yourself a cylinder without a top and the bottom. And that piece of paper, the height of the paper is the height of the cylinder, and the width of the paper is how long it is all the way around, which of course, because of the circle, would be 2 pi r. So every cylinder has a very similar net. It's got 2 circles and then a rectangle that is the dimensions of the rectangle are the height times 2 pi r. All right, now that you know that, let's do these 2 example problems. The first one, problem 3, is asking us to find the lateral area and then the surface area of this cylinder. So push pause and try this example problem on your own and then come back and see how you did. All right, problem number 3 is asking us to find the lateral area of the cylinder. So let's draw a little net of the cylinder like the one I just took from the previous page. And right there is going to be my lateral area, right? The lateral area is everything except the bases. So to do that, what we know is that the area is the base times the height. So it's just a rectangle. And in this case, that would be 2 pi r times the height. And so we know the radius is 5 meters and the height is 11 meters. So that would be 2 pi times 5 meters times 11 meters. Put all that together and I get 110 pi square meters. So that would be the lateral area of this cylinder. And if I asked you to round it, you could just, multiply by 3.14 for pi and get whatever you needed to get. All right, the next question B is asking us to find the surface area of that cylinder. Well, the surface area is just the lateral area plus the bases. So there's the base 1 and there's base 2. And so I need to find those. And so the area of a circle is just pi r squared. So that would be pi 5 meters squared. So each of those bases is 25 pi square meters. Since I have 2 of them, I would multiply by 2. So that would be 50 pi square meters. And as I just said, the surface area equals the lateral area plus the bases. So that would be 110 pi meters squared plus 50 pi meters squared. That would equal 160 pi meters squared, or square meters. All right, let's take a look at problem number 4. Suppose that a cylinder has a radius of r units, and that the height of the cylinder is also r units. The lateral area of the cylinder is 98 pi square units. Given that information, first find the value of r, and second find the surface area of the cylinder. Okay, so push pause and try this problem on your own and then come back and see how you did. Once again, here's the net of the cylinder, and this is the lateral area. And we know that the lateral area is just a rectangle, base times height, 2 pi r times h. And so that would be 2 pi r times r, because we know that both the radius is r and the height is r. So and we know that that's equal to 98 pi square units. So 2 pi r squared must equal 98 pi. If I divide both sides by pi, I've got 2r squared equals 98. Divide both sides by 2, and I've got r squared equals 49. Take the square root of both sides, and I end up that r equals 7. All right. Now to find B, I know that the surface area is just equal to lateral plus the bases. And here are my bases right here. And the area of a circle, of course, is pi r squared. So that would be pi 7 squared. That would be 49 pi square units. So both of them together, both bases together, would be 2 times 49 pi, or 98 pi square units. So if the surface area equals the lateral area plus the bases, and it told us that the lateral area was 98, and we just figured out that the surface area is 98 pi. If I add up 98 pi units squared plus another 98 pi units squared, I get that the answer is 196 pi square units.